Welcome back. It has been a couple days since the last one of these. Um, this is, I think, part six. I think part six. Today's date is the 20th, Wednesday, 20th of July, 2022, and I'm gonna be picking up, not quite from where I left off because I did a little bit of work off camera. Um, but let me just try to remember. I think we ended last time with getting the queries on the screen, right? And I think that was about it. I don't quite exactly remember what I did. I know what changes I've made since then, so I'll just jump into that. But yeah, I made some changes since last time off camera, so I'm gonna go over those briefly, and then my plans for this one are not quite what I said I would do last video. So I was talking to Guardian in the chat this morning about um, a lot of kind of adjustments for different widgets and stuff like that, which is going to happen. It's all going to happen eventually, right? So like have the image be central to the program, and then kind of have all your widgets floating on top, rather than having these kind of draggable panes that resize the image and stuff, which I like as an idea, but it's going to require quite a bit of work to do that. So that's not going to be happening yet, but it will eventually for sure, because I really want to do that. But last time, or I'm sorry, what I was talking to Guardian about this morning is having interactive grouping in the query as well, right? So you can, right now in the query, I'll show this in a minute or two, you can change the order of your query sequence. But what I was talking to with Guardian is that there also should be a way to interactively create like a grouping or precedence in the query. So I kind of want to get a start on doing that, because it's going to significantly impact how we write our widget, as well as it's going to require us to change some logic for some of the other kind of like data types that we've already written. So I'd rather get ahead of that now than try to add that in later. So I'm gonna do some of that now. So this one might be kind of a bit rambling, because I don't quite have a concrete plan for how I'm gonna do this yet. So I'm gonna try to feel something out, and then if this gets too long, I don't know. I might just kind of, if this gets too long and I find an implementation I like, then I might just finish it up off camera. And I didn't even mean to open that. If I don't, if this does stay super long and I can't think of anything that I like, then I'll probably just have another video of me trying to figure things out, I guess. It kind of just depends on how far we make it, but we'll get to that after I cover some of these recent changes. So it's nothing super crazy, but I'll go over it. So I'm just gonna close that. I'm using dark mode now. I don't mind using light mode. It's a little bit later in the day, so I'm gonna have dark mode to save my eyes a little bit, and also, maybe just as like a little bit of a visual change of pace. Um, so right, some of the changes that I made here is we're back here in this widget query request module. So I'll just start from the top down for this. So for this widget sentence branch, I added a new field to its constructor. It's just an ID integer field. That's just to help aid this equals instance, so that we can kind of have a semi-unique ID for each widget sentence branch as it's created. That'll help when you index the sequence. So like if you had I'm not going to give an example, but previously, if you had like two queries that were the exact same, and you tried to find the index of one, it would always return the index of the first one, right? Because if they're the exact same, we're using an index that looks from the left side of the sequence, so it'll always return the first one. And maybe we want to get the index of that second query. And that wasn't possible before, but now since we have an ID for each of these, now you can get the index of that second one, right? Because you just have another field to judge equality on. And all this index is just it's based on the length of the sequence when this gets inserted in the program. So our current constructor just sets it to a default of 0, and then that value gets changed when it actually gets inserted into the model's sequence on the front end. So kind of a minor change, but useful, I think, just for getting indices and stuff like that. Indices, you know. Next thing I did was I just handmade some lenses for this model, for this data type. So normally what I would do with lenses is I would just use template Haskell and then just have kind of like a template macro just automatically derive these lenses for me. But I already had these field names and I didn't really feel like changing them, so I just created these. So these have the exact same names as their fields, just with the word lens added on. And if you're unfamiliar with what a lens is just a way, basically, or at least the way that I use them, they can get really quite complicated. But the way that I use them is that a lens is basically just a getter and setter on a data type, right? So here we define this lens, and then this first function is a lambda that will just get the field I tell it to from the data type. And then this second one is a function that returns a function that sets that same field to whatever value we give it. So like this lens will retrieve this text field, and then you can also set that same text field with that lens. And then here I have a lens for each one of those, right? Just to keep things simple. So I'll talk about this in a moment. Here is, I just want to show you an example of a lens that I use here. So I use lenses all the time, not in this module, but in the handler. Right, like this is a lens. This is accessing, this is basically just the getter, right? This is going to the file selection model field of the model, and then you can use lenses in a nested way. So from the file selection model, it's then getting the selection. So really simple concept and extremely helpful to have. So I debated when I first created this data type on whether or not I was going to use lenses. I decided that I might as well, because I use lenses pretty much everywhere else in this project. So it's just something useful to have. So that's what these are. It's just some handmade lenses. And you can see they're very simple, really. Here what I created is a pattern synonym. So I've never actually made one of these before, but I was kind of lamenting the fact that I had decided to hide this constructor in other modules, right? So what I wanted to do really is with this constructor is be able to unpack this data type and pattern match on all of these fields. And because I decided that I would really like this type to be abstract, that I didn't want to be able to construct it, that meant that I didn't really have a way to pattern match with this easily. So enter the pattern synonym, and to use this you have to have this pattern synonyms language extension. So it's not something that's just baked in by default to Haskell, but it's a GHC thing, and I don't know, maybe other compilers have it, but you should just be using GHC if you're writing Haskell, honestly. But basically all the pattern synonym is in this case is an abstract constructor. So it just allows us to take a widget sentence branch and then basically just create a pattern for us, which is what this is, that we can pattern match on. So it's kind of like if we it's like a fake data constructor. So this is the name of the pattern, and then we can give it a type, and it'll allow us to pattern match on this, right? So I'm just repeating myself now, but that's all it is. So given a widget sentence branch, using this pattern synonym, you can then pull out the text, an integer for the count, and then here is a set op. So this set op actually, as we can see here, uses a lens into this sentence tree. So it's a little bit more of a complex pattern synonym. It has kind of like a derived field, if you want to call it that, to get this set op. but that's what it lets us do, is it lets us to just abstract or unpack this data type without having access to its actual data constructor. So we can keep it abstract, but still have all the benefits of being able to have access to its constructor to get the data that we want. So I thought that was very cool. That's the first pattern synonym I've made, but it's very handy, so I'm definitely going to be using those some more. Here's another handmade lens for getting a set operator from a widget sentence branch. So that'll go into it first kind of gets this field, and then it gets this tree, and from that tree it retrieves its set operator. So I believe I had a function that was similar to this in an old video. In, I don't know, maybe part 4, part 5. This is just the lens version of that function, so maybe I'm not quite making sense with my explanation of what these things are, but you know, it's just kind of a bunch of utility stuff. So let me try to think, what else have I changed in here? Here in our constructor, I have a way to go into this request after it's parsed and then retrieve its setop. So you either have to write an explicit set operator or it'll default to union. And what this lets us do is this lets us get rid of that global setop dropdown. So we no longer have to keep track of that global state. We can just rely on the fact that hopefully our user is familiar enough with the query language where if they want a difference or intersect, they'll write it explicitly in their query, and then we can just go into the query and then figure out what kind of setop they wanted us to do. So that's what this little let is for. Is it's a little case match on this to just pull the first setop that it sees out. So that's it for the changes in this module, and then I made some changes in the widget, or I added some events and then the widget too. So the events in brief are just events to move items in the sequence, right? So you can reorder the sequence, and then we have an event to delete an item from the sequence. So I think I talked about adding those in my last video, and that might have been what I had planned for my next one. I just decided to add those off camera. But we added those in and those work, so that's all cool. And then my changes in the widget are pretty much related to that, right? I just added some triggers for those events, like some extra drop targets, and let me try to find this thing here. We've got a drop target. We made it draggable. This, by the way, is how you make something draggable. Is you just have this little widget definition, and then you give it the value that you want it to drag, and then you just attach it to a widget. So making something draggable is even easier than making something a target for a draggable, right? So that's really easy. So that's the other half of my drop target explanation. Yeah, so yeah, let's see. We made that draggable. So this is how you actually reorder stuff, as you drag and drop, and then like we added a button to delete it. So here's the button that deletes a widget. So now we can run this and just kind of get a quick look at some things that have changed. I had moved that widget around. I made it its own proper widget also, so like now you can see it's floating up here. So it looks even worse than it did before, but that's alright, because I haven't forgotten to actually make it look nice, right? So here you know, we've got, it's kind of the same thing going on. So as you can see here on the left side, we don't have that setup drop down anymore, so this is an implied union because I didn't specify what I wanted it to be. It's an implied union by default. And now let's go ahead and we'll do the anti-embarrassment tags here. Right. I changed the name of that tag to suggestive. I think that's maybe a little bit more of a, I don't know, mature name for it instead of calling it saucy. Let's see. I think that's it. Do that. Right. So the numbers and stuff are still the same. Let's go ahead and I'm trying to think, what else do I got here? Let's just find all characters, or rather, let's just intersect with characters, because I can use this to show off kind of how the sequencing works. I messed that up. So here we go. We can demo the little delete thing, right? So I misspelled something, probably. I think that might just be character, right? I can just get rid of that. That's all you need to do. Character, there we go. That's a much more reasonable number. So let's run this query and kind of see what we get, right? They should only be images of UE, because we're just intersecting a character with the set of all characters, so it makes sense, like we still have a subset of that, right? There should be no suggestive ones in here. There we go, like that. Let's go ahead and then reorder this. So let's go ahead and I'm trying to think. This isn't really a very helpful query to demo this, so I'll just make a new one. Let's go ahead. I think I was doing this before, so we'll do UE Mio Honda and salute. Okay, so as it is right now, we're going to find every image of Mio and UE where they're saluting. This is a recent tag. I updated my test database now, so I used to only have 140 something UEs in here, and you know, now I've got over 300, so didn't want to disappoint anybody. Now let's see, we can move this salute here, so now we should only have like these 2 UE images and then all the Mios, like so. So now we can see we've got a lot. There's a lot of Mios in here. Some of them are, you know, maybe kind of sad. Some crying ones. That's kind of a little bit of an unfortunate image to stop on. So let's find something nice to look at. As you can see, like, you know, they're all kind of just in the same order every time. That's just how SQL returns them. I don't have any like different ordering going on. So I like this one, right? That one's pretty cute. So now that I've spent enough time kind of explaining the obvious and how these queries work, I think that we can probably move on to doing some more development. So 18 minutes in, and now we're starting on some stuff, right? So my apologies if that's all boring and obvious, right? So let me think. Where do we want to get started? We want to have interactive grouped queries. So just a little bit of a refresher. I'll just do this in here. A little bit of a refresher. So an example that I used this morning in the chat is that this query, here's an example of a complex query, right? So you have some tag A unioned with, or rather, intersected with the union of all B's and all C's. And then, right, so like here's an example of like some precedent query. This the set of all B's and all C's union together are going to be calculated before you intersect them with the set of A's, right? But what if you have in your GUI, you write this query, right? You have some A intersected with B, B unioned with C. Well, this is first going to intersect A with B, and then it's going to union it with C, right? So what we want to do is have a way to interactively like drop this C onto B and then create this query above. So that is kind of where I'm going to be kind of waffly in trying to figure out how I want to do that, because I have some ideas, but I'm not entirely sure yet how exactly I want to do that. So we kind of have to start with the structure of a query. So right, just going back to some of the AST stuff. So this A as represented as a sentence tree is just a sentence node, and then this B is a sentence node, and then this is a sentence node. What we want to be able to do is transform this sentence node into a sentence branch that contains the nodes B and C. So we have to maybe get a little bit creative with how we want to do that, and I think that it's going to require having some several constructors for this data type. So yeah, I'm gonna have to think about that a little bit, so I apologize maybe if I'm not quite super talkative, or if I can't get my thoughts in order about that. But I think probably what's gonna happen is that I'm gonna just talk out loud to myself for a little bit and not really get anywhere, and then probably off camera figure something out then that I'll talk about next video. But I'll work on this for a little bit, just kind of out loud, and we'll kind of see where we are after a little bit. So right now, the implementation for this constructor, as we decided, is that it only creates sentence branches. So no matter what is parsed, it's going to create a sentence branch, which is fine, right? But if we want to be able to drag and drop queries, you should be able to like take this C and then put it onto this B, and right now that just reorders them, but we can take care of that later without any issue. But you should be able to drop this onto B, and then you should end up getting hopefully some kind of token that looks like that instead, right? After dropping them, you should get something that looks like that. So there are going to be kind of several things probably that require changing, right? So we're going to end up with this new label that looks different than the combination of our previous labels. So we're going to have to like be able to like dynamically rewrite how the text in a query appears. So that right, we're gonna have to just write some format functions for that. So I don't think that's gonna be super bad. And then we want to be able to probably be able to actually handwrite a complex query like we just did, and then be able to treat that exactly the same as we would like dragging and dropping something like that, right? So there should be no difference between a query that you handwrite versus a query that you create by dragging and dropping stuff. So what's implied by that is that now when we parse an AST, we're going to have to actually unpack it and create widgets out of each component individually, right? Which is something that we're not doing right now. So we're going to have to change that. And then you're going to have to be able to, I think, as implied by some of the other things we talked about, you're going to have to be able to reach into this query and drag something out of it, right? So if I decide that I don't want this kind of precedence, I should be able to take this C out and then just drop it back at the end, and then you just end up back with this regular, back with this, right? So you should be able to construct and destruct these queries interactively. At least I'm pretty sure. I'm pretty sure it should be possible reasonably to do both of those things. At the very least, you should be able to construct them, and I think destruct follows logically from that. And should be doable probably. So that's going to require us, like I said before, to actually unpack our requests and um, make widgets for each one of them. So I think actually, now that I think about it, right? So in our front end, we have these two. We have this widget query request and this sentence branch, and they correspond to the request on the AST and to the sentence tree respectively. So if we go to those types here, we have our request and then our sentence tree, and then our sentence tree contains a sentence set. Excuse me. So I think what we're going to have to do is create an analog to this sentence set and then actually create widgets out of these. So I definitely think that's what we're going to have to do. So we can just start with that. We can start with that for sure. So let me think exactly of how I might want to do that. This is probably going to cause us to have to just delete these lenses or rederive them. So I might just end up switching to template Haskell to make those, because I don't really want to have to rewrite those. It would only take a couple minutes, but being lazy and all that. Let me think. Let's see how long this is going. Have a quick drink of water while I'm thinking. I think actually we wouldn't need to create an analogous type for that. I think that we could just use just plain sentence nodes or sentence sets. I think I'm kind of getting ahead of myself and thinking a little bit too far ahead, so I'm gonna just start with something simple, right? So kind of our first requirement with getting that working is having the text kind of dynamically rearrange itself, right? So let's just make a format function that kind of just pretty prints these things for us, and then we can just use that when we create our label. Maybe that's not the wisest place to start, but I think that's going to be what I'm going to do. So we'll just go ahead and just do format sentence set. Right, it's going to take a sentence set text and then just output some text for us. Okay. After we get our formatting right, then I'm going to create some functions that will allow us to combine and then extract these from within a sentence branch. And then after we do that, we will go ahead and I guess maybe just start making widgets for it. I don't think that we have to actually redesign any of our types in here. I think that those are probably okay how they are right now. We can just create some functions for these sentence sets and sentence trees, and then kind of compose them with our types here. So I think that that's probably okay. Like I said before, I could be totally wrong about this, and could just be a waste of time to do this, but it's kind of what you get when I've not quite settled on the way that I want to implement something. I'm gonna be kind of wishy-washy about it. It's how I pretty much always am. So we'll figure it out as we go. So let's see. Here's our sentence set, and then that's just a sentence. So first things first is just formatting a set operator, so we can just have a separate function for that. Yeah. Yep. I'm just thinking for a second. All right. I'm pretty satisfied with the thought that I just had. So let's see. We need to add some overloaded strings to this, so that we can actually write text literals, because text is not part of Haskell. Dumb thing about Haskell is that strings by default are just a linked list of characters. So if you want to have like actual sane string implementation, you have to use text. And to use string literals with text, you have to use overloaded strings as a language extension. So that's kind of just maybe one of the dumber things about Haskell, I suppose. I mean, not like that I really know anything, I guess, but you were just gonna pattern match on our different setups here, like so. Okay, and then here all we can do is just do format setup so, and then just have our trusty semi-group concatenation function. I don't even know if it's technically supposed to be a concatenation, but okay. So pretty printing sentence trees is going to be where it gets probably kind of weird. Right, so I mean, this kind of necessitates, honestly, like just starting from the bottom and then having formats for all of these structures, which is kind of a pain. And maybe it'd be better if there was a library function for that. But if I had written an actual library function for pretty printing, it almost certainly wouldn't be something that I want to use on the front end for my widgets, so it's probably okay. I would like to try to keep the text as close to what the user entered as possible, but it gets really difficult when we do talk about having to actually rewrite those strings when you create a new combination. So I'm really not sure about that. There are ways that we could probably do it without that. It would be really kind of jank. Hmm. Like we could just take these terms and then like literally just put like parentheses labels around them, and that would be kind of a hack solution, but it would work. You would end up with something that looks like this probably. So you would probably get which right, because this I pipe is part of that query literal. So like if we were to literally just take these and then just put parentheses around them, you would end up with this, which is like, not valid syntax for the query language at all. So that's actually really bad to do that. We wouldn't want to do that at all. I'm pretty sure that's not valid syntax. No, it definitely isn't, right? Because like this would have to go outside of the parentheses. This would have to at least look like that. Um, and this even is not doing what we want it to do, right? Because implicitly this is actually an intersection when by default that C is actually a union C, right? So this actually defaults to that. So I was kind of hoping that we wouldn't have to, but I really do think that we are going to have to just write formats for every component of the AST to like do this in a sane way, probably. So, and maybe the benefit of this would be is that, you know, once we pretty print the AST for somebody, they can see like you know, it'd basically just be like formatting the language, right? So like maybe it would look nicer to them or something if we did that. So why not? Let's just go for it, right? And just write all these. So let's see. We got to start with wherever the term is, term, right? Got to format the term. Okay. I'm gonna. Oops. I'm just gonna turn that warning off because I don't like seeing that. Get rid of these. We can just import the entire module and then just refine that later. Format term. Here's our term. Here is our query criteria, and then here is our text. So then now we need a format query criteria. I wouldn't expect you to stay and watch this whole thing, right? This is probably going to be the rest of the video, honestly, is just writing these format functions. So if you get bored here, I don't know. I'll let you know if I stop doing this by the time the video is over, but I think I'm probably going to write a couple of these and then just end the video and then write the rest of them off camera, and then next time we can do something a little bit more interesting, right? I think that's probably better that way. Let's see. Good news is that once we get this actual term one written, the rest of them should be very simple. So I don't know why I'm making all these typed holes. We can just do this. That's a D dot, R dot. I think that's file pattern criteria, P dot, U dot. Okay. And then now let's see, this is simple. So now we just do format query criteria QC. And then we don't want any spaces, right? Because syntactically there's not supposed to be any spaces, so we can just do that. Okay, so we've got our term. Let's go ahead and then just right, like we could write one for this simple term, and I suppose we might as well, even though it's literally just a new type. Simple term T. Format term T, like so. Just do that. Now format complex term. Bottom T is format term T. I think we can just do that. I don't know. We'll have to wait and see how this looks. Hold on one moment. Okay, so let's go ahead, and here is our first term here. And then here is the rest of our complex terms. So this is going to require, like, slightly more thought to do that. So I think what I'm going to do is ignore that for now and then come back to that. And then just format our sentence set. Simple st. Oh my gosh. It took me a second. Format term tree. Complex CT is. There we go. Do that. Here is a sentence. Format sentence. There's our term trees. So I think what we can do for these is probably just unwords those. T dot unwords, and then for this we can just do format term tree TTS. Yep. Okay. And then now here we go. We can just do format sentence S. Okay. There's our functions halfway written. Okay, so let's see, a complex term. Syntactically, those are written with our curly braces. So that's going to be how we represent these here. So this is just format term T. There's our curly braces. We'll go ahead and just have a space between them just to keep things legible. Like that. It should be good enough to get us where we want to go. Okay, and then let's see, non-empty. So we're going to want to probably just unwords that as well. So we'll do unwords trying to think, hopefully I wrote that right. Import non-empty. Non-empty is a cool type. I haven't used it all that much, but it's definitely probably a good idea to get in the habit of that, of using it, because it's pretty helpful. Alright, what is the problem with this? Oh, let's see, unwords is unwraps text. So what we want to do, or what is the issue with that? T dot unwords? Okay. I think that probably works. Works for us. It probably wouldn't be super difficult to test this real quick, but let me just think about it for a moment. We've got our format sentence set. Let's go ahead and just try to test this. We can open up a REPL here. You can see how the Cabal REPL works, which is kind of handy. I think that's all we need. Add some modules here. So we need our text.taggerql. We actually don't need that. We just need the parser. Parser.internal, and then we need interface dot handler. Excuse me, sorry. Oops. I think that's it. This command requires an interpreted module. Oh, it's from another package. Alright. It's just because I put that little star there. We can take that off. We don't need that. Okay. We want to set overloaded strings because our parser requires text. And then now what we can do is we can just get a parse result. So I think that we should be able to probably just parse. I'm trying to remember exactly what are the names of these things. Okay. We have a sentence parser. We don't have a sentence set parser. We have a sentence tree parser. Let's do a sentence tree parser. Sentence tree parser. I think, let's see, we need a stream name probably, and then now we can write our stuff in there. So we're parsing a sentence tree, so it can be either a node or a branch. So let's go ahead and then just try parsing a node. So let's just do that. Does that work? Okay, that did work. So yep, there's our syntax tree for that query right there. And then it's wrapped in an either, just in case, you know, the parse would fail. So let's go ahead and just try either print, and then we'll have some function there, and then on our result. Oh, hold on, I'm not very bright because I only have that for a sentence set. I don't have a way to actually format the tree. So I need to get the sentence set out of that. So that's fine. We'll just unwrap that. Let's go ahead and just do... Okay, I'm going to use a module that I don't have imported yet, so this is going to fail the first time. But I'm just going to do... I'm just going to use text to print that. And then... format sentence set. And then some value ss. So here we've got this write, or rather we have a sentence node. I think that I can probably just write a partial lambda, and then, you know, we'll just pattern match it on that. I'm getting kind of like rambly as I think about this. Sorry. We're formatting the sentence set. The sentence set is constructed with the actual sentence set keyword. So I think that's actually all that we need for that. Here's our sentence node. Yeah, okay, let's try that. And then import qualified. Trying to remember the module name. I think it's data.text.io. Okay, so there we go. There is our formatted tree, right? So I'm trying to think. This may not be syntactically proper because I think that there may be a space that's expected between those. So we can try just parsing that again and seeing what we get. Let's just try entering it as is. Oh, it's a write, so that still worked. Here, I'm gonna just put the parse in there. I'm having a hard time reading this. Hold on. Parse sentence tree parser. Okay. Let's try I don't know. I was gonna say we can just try putting some garbage in, but let's actually try formatting a more complex thing. Right. Let's go ahead and then let's do this. I'm gonna try it without spaces and see also if that works. Cute portrait candy. That was when I was searching today. There we go. So that's not too bad of a format function. So now let's go ahead. Let's see, that's a sentence set. So we actually do need to have a format sentence tree, or yeah, format sentence tree. We'll go ahead and write that, and then we can test that. Yep. Sentence node. Here is our sentence set. Sentence branch. Here's our set op, and then here is our list of sentence trees. Let's call this SSS. SSS. Format set op SO. And then we don't care about if that's spaces or not, but it does need to be between some parentheses. Okay. And then for this, I think we can probably just do the same thing we did before. We can just use unwords on that. T.unwords dot, and that's just a list. So we can then just do format sentence set. Or is that? Oh, those are sentence trees, aren't they? Format sentence tree. Okay. Should work. Let's go ahead and reload this and we can test that. We can get rid of this lambda entirely. Format sentence tree. We still need that put string line though. Do that. Okay. That's the same as it was before, right? I'm not losing my mind or anything. Hold on. I lost my place, whatever. It's a pure function, right? How would that be any different? I'm losing my mind, just don't pay attention to me. Okay, let's go ahead and then try... Let's see, this is a sentence tree parser, so it only parses one at a time, which is fine. So here is kind of like the explicit version of the query that we wrote before, right? There's our complex query. There we go. So there's our formatted query, right? So this probably is really honestly not super pleasant to look at, but let's just go ahead and then we'll change these, and just with like some other tags. Maybe it'll look maybe it'll look nicer if you just have like actual tags. Probably not. How about let's do that. I'm kind of confused. Does it actually just like, does it let you do this? I've never even tried that before. I'm learning things about, potentially learning things, unless I probably just wrote this wrong. ut.candy. I'm curious about this. What in the world? Did that work? I never would have even guessed that you could actually handwrite a term like that. I didn't anticipate you being able to do that. Not that it matters, but I just learned something new about the parser that I wrote, that it lets you do that. Which I suppose it's pretty obvious that maybe it would, but I'd never even tried doing that or considered it. Well, that's cool, I guess. Maybe, I actually did know that. I just forgot about it. I actually did know that you could do that. So. There's a little fish for our prompt. Alright, I'm about done now. I'm gonna just write this one. I'm kind of just messing around. And then I'll be done with this. And then next video, I will go ahead and write functions to construct and destruct those. And then we can start creating some events for doing that on the front end, right? So, sorry, this was probably, pretty boring, and it's pretty long too. But I guess thanks for watching if you made it through the whole thing. Otherwise, I apologize for spending the entire time writing functions for formatting strings and talking about small changes that I had made. But, next time could be more exciting, could be. So I suppose stay tuned for that if you still want to see those. But I'm just going to, finish this query just to see what it looks like. And probably talk to you next time. Yeah, see, now that I'm here, I don't really know what I want to do. Oh, this does need to be complex query, doesn't it? Now that's what I'm talking about. See you next time.